just a second, I'll ask you some questions. But first, just a little bit of, orientation. So the exam will be tomorrow. You have the window opens 10 minutes before your class, and it closes 10 minutes after your class. That means you have an hour and 15 minutes or so that window in order to take the exam, but you only have an hour to take the exam. So make sure that you have time set aside, a place, a nice quiet place, preferably somewhere with a table that you can, get away from everything. Make sure when you're doing the environment check that you follow what I did on the sample that I sent you a few weeks ago, where you take your laptop and you sort of show me everything. You will be allowed to have 2 sheets of blank paper. I think that should be plenty for you. Make sure that you show me those, both sides, in the environment check, and then also show me your calculator. Open up your calculator, show me the inside of the cover. I just want to make sure that everybody's on the same playing field. There are 29 questions. One of those is a gimme question, so make sure you get that one right. It's like D or whatever. You've seen those on my exam, so make sure you get that one right. And it's going to be from chapters 1, 2, and 3. Chapter 3 only up through vectors. So those are videos 1 through 4 on the online lectures video. All right, what are your questions? Things you want to look at right off? Chapter 2 for kinematics. Okay, well, I have the fall 19 exam. Are there any particular questions that you want to look at from chapter 2? And chapter 2, we had kinematics. Those are like calculation questions. We had free fall, which is really just another type of kinematics calculation. You're going to have 1 or 2 questions that'll be very specific free fall questions. We did some of those in class the other day. And then also the graphing things, quantitative and qualitative. Let's just look at some of those. Hey, come on in. So which of those classes you want to look at first? The calculations or the graphing?
The calculations.
Okay, that's what I thought. All right, so this is fall 19. Let's look at number 11 here. Fall 19, number 11. A car is traveling at 4 meters per second and begins to decelerate at 2 meters per second squared until it stops. What is the distance it travels? So this is a 2-step problem. I don't really know that right off, actually. Really, what I want to do as I start is just write down everything that I know. I know that V0 is equal to 4 meters per second. That the acceleration is 2.0 meters per second squared. And then I need to think about what is the sign, because I tell you that it's slowing down. Slowing down doesn't always mean negative, but in this case it does mean negative, because the velocity is positive, it's slowing down, so the acceleration is opposite the velocity. So that's going to be negative 2.0. And I want to know what is the distance, x, equal to. I recommend that when you start your exam that you just write down the equations for this chapter. There are really only 2 equations, and those equations are these: x equals v0 t plus 1/2 at squared, and then also v is equal to v0 plus at. So I have those 2 equations. If I'm looking for x, then I'm definitely going to have to use this one. And I know what V0 is, and I know what A is, but I don't know what T is. So I have to figure out T. And then that's going to be a clue to you that, hey, probably going to have to use this one. You are not going to have to do substitution to solve a system of equations with 2 unknowns. I won't have you do that. I know in some of the homework problems that was the case, but I won't do that on the exam. So I say V is equal to V0 plus AT. V, I don't have V written down. However, I know that at the end it stops. So that means that V final is equal to 0. So 0 is equal to 4 minus 2 times t. So t is equal to 2 seconds. Then once I have that, I can find x is equal to v0 t plus 1/2 at squared. That's going to be 4. That's my V0 times t, which I have now is 2, plus 1/2 of negative 2 times 2 squared. Very important to get that negative sign, because if you don't put the negative, instead of getting the answer, which is 4, you would get 12. And 12 is an option, but that's not the right answer. So very important that you get the sign right. Important that you recognize that this stops is our v final, that is equal to 0. Important that you know these equations. I think you all know the kinematics equations. We've used them enough. But I just recommend you write them up at the top of your scratch paper. That way they're there and you see them after you start your exam. Okay, you understand? After you start the exam. Okay, so 4 is the answer there. Let's take a look at any questions about this one. Look at some others that are similar. I recommend lots of practice. That's the way you do well in these exams, is to practice, practice, practice. I don't see any others on this one, so I'm going to go to a different exam. See, I'm going to go to some of those that are different from in your book. So let's go to fall 2014. Fall 2014. Can we do 17 and 18? These are similar. I know we did this in class, but you're definitely going to have them. So I just want to make sure that everybody's on board. And I think I put 2 free fall questions. So hopefully those are gimme questions. That you have the 4 vector questions and then the 2 free fall questions. That's 6 questions. That's like a quarter of your exam or a fifth of your exam almost. So I want everybody to get those exactly right, 100% on those questions especially. So number 17, I throw a ball up with a velocity of 10 meters per second. How long does it take to return to you? Can you answer that without even really working it out? What is it? And everybody says, if it starts out at 10 meters per second, it goes up and comes back down again. How long to get to the top? The total time is 1 second, or I mean, it's 2 seconds. The time to get up to the top is 1 second. So my answer here is 2. Let's just go through that right quick. So v is equal to 0. V initial is 10. And so I say v is equal to v naught plus at. That's 0 equals 10 minus 10 t. That's my acceleration. So t is equal to 1. T equals 1 at the top. That means t equals 2 at the bottom. And then how high does it travel? If I want to know the y position at any time, I can use this parametric equation. Y is equal to v naught t plus 1/2 at squared. At t equal 1 second, which is when it's at the top, I can just say v naught was 10 meters per second times t, which is 1 second, minus 5, that's half of negative 10, times 1 second squared. 10 minus 5 is 5 meters. So B is the right answer there. No excuse for getting those wrong. They're not that complicated. It's just you need to practice them a little bit. So no excuse if you get that one wrong. I want everybody to get it right. Right? No excuses? No excuses, right? I get those right. Okay. And look at this problem. You're going to have a couple of these at least where I ask you to analyze qualitatively the graph that I give to you on the test. Remember, for a position versus time, x versus t, the slope is equal to the velocity. So if I'm, in this case, I want to translate from a position versus time to a velocity versus time. And so the value on the velocity versus time graph will correspond to the slope on the position versus time graph. So for example, is my slope big or small right here? I have a big slope, and is it positive or negative? I have a positive slope, so that gets rid of those two options. And I have a big slope, that means it's going to start right here at a big value. And then just to check, it gets small right here. So here I have a small positive slope. So this, option C, is the right answer. You'll have one of those, right? Let's try a different one. What if the graph instead, let's see, looks like this? What would the answer be? If this is a position versus time graph, what would the answer be on this one? Y'all agree? D? Let's take a look. So I have a big or small? Big, negative or positive? Negative. So I have a big negative slope. And so it looks like D is the right answer. No excuse for getting those wrong. Really, there's no excuse for getting any question wrong because you worked through all of these questions. It's just a matter of, have you had the time to sit down and practice them? Or do they come to you really quickly? And they can come to you really quickly. You just have to practice them. Okay? Definitely going to have a couple of these on there. All right? The test actually will look a lot like previous exams. I just have a spreadsheet that tells me how many questions from each topic I want to have. And that's not always constant. Sometimes I vary it just depending on the class. But your exam will look very similar in the way it's laid out. It's just the questions will be different. But very similar, but different. Same content, just different questions. Okay, what else, shall we? Get more graphing, dimensional analysis, estimations. Anne-Marie?
I have a specific question.
Go ahead. Ooh, I don't have my notes.
Okay.
Can you show it to me?
Yes. It's just a quick test.
Sorry, I left my keys. Okay, so this is on page 55. I'll just write it right here. It says that a vector A has a magnitude of 12. Yeah, we didn't do this in class. I'm sorry. I thought we'd done them all, but now I'm seeing that we didn't. And then vector B has a magnitude of 25. And it asks which is a possible sum, 55, 38, 32, or 9. What will help you on these is if you go through the concept test. You go through the concept tests that are on Moodle, then you'll see questions like this that'll help you practice. And then, of course, in the old exams, too. The thing is, with these two vectors, there's a minimum and a maximum that you can get when you add them. The minimum is when I have the 25-unit vector in this direction and the 12-unit vector in that direction. And in that case, the minimum of that sum is going to be 13. 25 minus 12 is 13. So that's the minimum value that I can get when I add vectors A and B. Any other sum of those two vectors is going to be something bigger than 13. And the maximum is going to be when the 25 and the 12-unit vector are in the same direction. And in that case, it's going to be 37. 25 plus 12 is 37. So the answer has to lie somewhere between 13 and 37. So for example, if I have my 25 and my 12 like this, that's going to be something less than when they're in the same direction, but more than when they're in their opposite directions. Right? Those are the minimum and maximum values. So between 13 and 37, it has to be 32. That's a great question, and you'll have questions that are similar to that. So that question in particular came from the concept test. So go back and look at those, print them out if you're able. I print them out. I don't really study for your test, but if I did, I would print them out with 6 slides to a page and then fold it in half, and then you can sort of quiz yourself on all those for chapters 1, 2, and 3 concept tests. Okay? Are they in the back of your workbook too? You can go through and look at those. And the concept tests give a description of how the answer comes about. Good question. Other particular questions? Particular problems on test? Are topics that you want to look at? Chapter 1, remember, was dimensional analysis, trig, conversion of units, estimations. Yeah, graphs. Okay. Like this one? Okay. You're going to have 2 or 3 questions like this. In this one, it's a position versus time, and I'm looking for the average velocity. This is an important word, average. That means that I'm looking for the velocity between 2 different points. And so I know that because I give you here 2 different times. I'll show you another one where we're looking for instantaneous velocity. I'm not going to say instantaneous in that case. I'll just say velocity. So be looking for that average. There is an equation for average velocity. I don't really think of it as an equation. but it's equal to delta x over delta t. My change in x over my change in time. And so between t equal 15 and 25 seconds, that's equal to, at 15 seconds, it's right here. And at 25 seconds, it's right here. So it's 30 and 10. The initial is 10, or excuse me, the final is 10 minus 30. Right, that's x final minus x initial divided by the time. So 10 minus 30 divided by 25 minus 15. That's -1. So B is the right answer. That's finding the average velocity. I'm looking for the slope of this line right here. Let's look at another one, though. That one's probably one of the easier graphing problems. Let's look at another. If I ask for the instantaneous velocity, in this case at t equal 8 seconds, then what I'm looking for, or if I were just to say velocity, that would be the same. What I'm looking for there is the velocity at this point. I'm going to give you one time, so that should be a clue that I'm really looking for the slope of this line. Remember to find slope, some things to be careful about is that you don't count the squares, because if I were to count the squares, I'd say 1, 2, 3, 4, 5, 6 divided by 1. Is that an option? No, it's not, but it usually is. Don't count the squares. Instead, look at the numbers. Grace?
No, that's probably just erased. The answer's going to be -2.
Is that not what I put?
So it's,
Oh.
10 minus 30 over.
Yeah, you're right. Let me fix that. So the previous one should have been 10 minus 30 over 10, right? 25 minus 15. So that would be -2. So I was going so fast, and that's going to be a caution to you on the test is that I know I've told you that you need to go fast, 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 but don't go so fast that you just make silly mistakes like that. Right? That was silly, right? Got a question, John? Yeah, it should have been -2 for the average velocity. I'm sorry, I just wasn't thinking, right? Wasn't thinking that I thought I knew how to do it, and I did, but I was just going through it so fast that I made a little mistake. All right, so the instantaneous velocity is rise over run. That's 30 minus 0, 30 minus 0 over 10 minus 0. And so it's 30 divided by 10, or 3 meters per second. C is the right answer for 14. Okay, let's look for, I don't think I have one on this. I'm going to go to a different one, okay? Let's go to fall 13. I think it's in exam 2. No, exam 1. This was back in the day when I used to call them quizzes. And I thought the students would like them better if they called them quizzes. It makes them seem less important. But they didn't like them any better. It was sort of the same. All right. Let's look at number 9. I like this one. I'm going to blow it up a little bit. I have this graph, and I ask where is the speed greatest? At 45, 55, 38, or 10? And so I'm going to look at each of those. I'm not going to calculate the speed at each of those, but I'm going to sort of look at the lines. That's at t equals 10. At t equals 38. That's like right there. Sort of looks like that. At t equals 55 is a line that looks like that. And t equals 45 is right there, is a line that looks like that. Where is the speed greatest on this graph? At the 45 seconds, right? Because at 45 seconds, it has the biggest slope. And so the biggest slope means that it's traveling faster. It's traveling in the negative direction. It has a speed of, looks like it's about -4 meters per second-ish, looks like. And so it's traveling faster than at any other point because the slope is a lot bigger. I don't see any other good ones there. More graphing or something different? Yeah.
You know, like the vector problems, where you have to, Kinematics and lines.
Of course. Let's go to fall 19. Is that exam 1? I think it might be exam 1. No, exam 2 on fall 19. Vectors are really important. Oh, shoot. Oh, here we go. Yeah, vectors are really important, and you'll have 3 or 4 questions. I think I put 4 questions. I think there were like one calculation here, like number 11, one like number 12, and then I think there were a couple of conceptual questions that are similar to ones that we've done. So number 11, I think it's always useful to draw a picture first. So I start by drawing a picture. I have 6 units at 60 degrees. And then 2 units along the negative y-axis. And I want to know the magnitude of those 2 vectors. I can get rid of some answers. How many can I get rid of? I can get rid of 1 answer. Which one can I get rid of? What is the maximum value I can get by adding these 2 vectors? 8. Yeah, the maximum I can get is 8. So that gets rid of E. So now I just have 4 options. My first step is to find the x and y components of the vectors that are off axis. I will only give you 1 vector off axis. So in order to do that, I like to draw a picture again. The y component is 6 sine of 60. That's equal to 5.2. The x component is 6 cosine of 60. That's equal to 3. And then I have 2. That's the first step, is finding the x and y components. Also be very careful that you're drawing the vectors correctly in that very first step. This one was fairly straightforward, but I'm just looking for where is my angle measured from and what axis is that vector on. So just be careful that you draw those correctly, because if you don't, you could get an answer that's likely, possibly an answer that's available. Next, I add up my x and y components. So I have 2 vectors on the y-axis, 5.2 and 2. So 5.2 minus 2 is equal to 3.2. And then here, I just have 3. And then the final step is to figure out what is this resultant vector. And that's where I have to use my Pythagorean theorem. And I say square root of 3 squared plus 3.2 squared. I get 4.4. So B is the right answer, 4.4 units. All right. Good question. You're going to see it. It'll be really, really, really similar. Numbers will be different. The angle will be different. Axes might be different. But you'll follow the same procedure. Like we did in class the other day, I did post a video, by the way, in the help sessions. So if you're struggling with vectors, you might want to revisit that. We did that for everybody in class, but it might help you to revisit it. You'll have one like number 12 as well. What is the vector A plus B? In this case, I draw the vector A, then I draw the vector B, and the resultant starts at the beginning, ends at the end, so B would be the right answer. I just pick out the right vector. Definitely going to have one just like that. I give you 2 vectors A and B, ask you for A plus B, A minus B, B minus A, be able to do all those different possibilities on that question. Okay. That's chapters 1, chapters 2 and 3. What about chapter 1? Y'all good on chapter 1? Estimations you're good on?
Their method is formulas, right? To simplify and keep it out.
Okay. Yeah, those are often a sticking point. This is exam 1, fall 19, so last year's exam. Look, you're going to have a question like number 4. I think I also have a question like number 3. Those are pretty common things that I put on the exam, so be prepared for those. Which of these equations is dimensionally correct? Oh gosh, I think I did this in class the other day. No, it was something similar. Actually, can you tell me which of these are correct? Can you look at those and tell me which ones are correct? All of them are correct, right? Because these are all my kinematics equations. Gosh, that was an easy question, right? And now you have a little equation sheet on the first page of your exam. All of those are correct. Let's just do number 2, and we'll show how that one's correct because it's sort of the most complicated. X is meters. V naught is meters per second. The naught doesn't really affect the units. It's just like V. Seconds plus half doesn't have units. It's just an integration constant. Meters per second squared. Second squared. And then I go through and I cancel things out. So I have meters, meters, and meters. So all of those have the same unit, so it is dimensionally correct. We'll look at another one. Actually, let's look at number 3. In number 3, I want to find out the units of R. Oh, that was a little tricky. Okay, so I want to find out the units of R on number 3. And so what I have to do on this one is solve the entire equation for R. And so it's going to look like this. R is equal to mv squared over t plus mx squared over t cubed divided by v. And if I find the units of that, then it will tell me what are the units of R. Now, something that's really important, and I do tell you that the equation is dimensionally correct, is that these two terms must have the same units. In fact, they do have the same units. So I just need to find out the units for one of those terms, and then I can solve the whole thing for the units of R. Whatever the units are on that right-hand side will be the same as the units for R. So I have kilograms, meters per second squared, 1 over seconds. Can y'all see that okay? 1 over seconds. That's just the units for this. I'm going to go ahead and assume that it's the same as the units for that. It better be, or else I was lying to you that the equation is not dimensionally correct. Divided by meters per second. If I rewrite that a little bit, kilogram meter squared over seconds cubed, that's just this part, times seconds over meters. That was this part brought up into the numerator. So I flip it, and then I can cancel things out. This meters cancels with one of those meters. This seconds cancels with one of these and leaves me with seconds squared. So I should have kilogram meters per second squared. And that's option C. That question is probably a little more difficult than other questions that I've given you in the past, but that's okay. Like you should expect a variance sometimes in these questions, that you might see one that's slightly more difficult than ones you've seen in the past. Don't expect it to be the same exam. Even if you're really good at working through all the old exams, if you really just memorize those exams, that's not enough. That you really need to have internalized, the concepts and the ideas and be able to apply them in similar but different situations. Race? You sure?
Yeah, I was trying to figure out why they'd be the same.
Oh, why those units on the top have to be the same? Yeah, it's important because you can't add apples and oranges, for example. But I have to.
It just wasn't lined up at first, and I realized where I was.
Well, we can see if they had the same, right? So I'll go ahead and do the units here. That's kilograms meters squared per seconds cubed. And these would be kilograms meters squared per second squared times 1 over seconds. So in fact, those are the same units for those two terms in the numerator. Okay? All right. How are you guys doing with estimations? Let me just take it. Never mind. I'm not going to ask. Well, let's just take a second and look at them, because students, for some reason, like that's what they struggle on. Let's look at, let's see what fall 15 has for us. Well, these are some good ones. A mid-sized car has an approximate volume of what? Now notice they're all factors of 10. So while you might get a different answer than I do, but you should be able to pick out the right answer from what I choose. So a car has a width. A car is basically a rectangular prism with wheels, and it has a width of about, 2 meters, right? And it has a length of about, oh gosh, how long is a car? How many? I mean, I'm about 2 meters, so that's sort of what I'm using as a measurement. Like if I lay on my car, I can lay across the whole width of it. 5 meters? Maybe. Let's just try 5 and see what that gets us. So 5 meters long, and then a height. See, it comes up to about here. Maybe, let's just say 1 meter. So I have 1 times 5 times 2. That would be 10 cubic meters. So that means I'm going to have to choose 15. Okay? Double check that. Number 1 better be A, hopefully. Yeah, 1 is A. All right, because really a car that would be 150 cubic meters would be 10 times the size of this, theoretical car that I've constructed in my mind. Or a guy can try kayak about what distance in 10 minutes? A guy kayaking just sort of normal is about how many meters per second? Ish. Ever go kayaking? No. Well, you have some idea. It's about a walking speed, right? And so a walking speed is about a meter per second. That's what I was shooting for. So if I have about a meter per second, in 10 minutes, I would do a little conversion. And sometimes on these estimation problems, you're going to have to do a conversion. Like you might do the estimation in centimeters, but I ask for the answer in square meters or square millimeters or something like that. So it might be a unit conversion problem combined with an estimation problem. So 1 meter per second over 10 minutes. I need to convert that 10 minutes into seconds. So in 1 minute, there are 60 seconds. And then all my units will cancel out, right? That goes with that, that goes with that, and I'll be left with meters or 600 meters. So in 10 minutes, he can go approximately 600 meters. You'll have a couple of estimation problems. Lately, I've gotten into giving these problems where I give you some shape on the screen like that. You'll see those, and I'll ask you, what is to estimate that? And often, I'll ask you, the options will be in some unit that's not really appropriate. Like if I were to ask you that, like on your screen, it's about this big. If I were to ask you that, but then I would give the options to you in square meters or in square millimeters. And so you have to figure out the units of that in centimeters. Let's say that this one is 3 centimeters on a side. It's not really, what is it? It's really about a quarter of a meter, about 25 or 30 centimeters. You follow what I'm saying? That's not really a centimeter, but on the computer screen it looks like a centimeter. You follow me? Okay. That's not really my point. So my point is that if it's 3 centimeters on a side, then it's going to be 9 square centimeters. And then you need to convert that into square meters or square millimeters. Be careful in this. Make sure that you square your conversion factor. Right? When you do your unit conversion, you have to square the conversion factor. So if I'm going to meters, I would say in 1 meter, there are 100 centimeters. And 9 divided by 100 squared is 9 times 10 to the minus 4 meters. So that would be my answer. Okay? All right. What else can we look at? We did vectors, we did kinematics, we did graphing, dimensional analysis, estimations. You okay with sig figs? All this is going to be in there. I'm going to do a sig fig problem. I think y'all probably good on it. Well, let's just look at it and get the whole gambit. So on this one's not terribly difficult. I give you what you would get in your calculator, and I ask you to report the one with the appropriate number of sig figs. When it's only multiplication or division, you just look at the lowest number of what? Decimal places or sig figs? Sig figs. So in that case, it's 3, 8.47. Okay? You need to know your standards. Make sure you know them. Be careful because sometimes it'll look a little bit confusing that it might be an old standard, like the bar in France. That's the former standard. Or it might look like a standard that is similar to another one, like the cesium atom is really the standard for time, not for the meter. This is, I don't think that was never a standard. So A is the only answer. Just know those different standards, okay? Know your standards. Remember that for mass, the standard is now based on what? Remember, it has a new standard. It used to be a cylinder with Planck's constant. And that is paired with a watt balance after James Watt. Like your power, you have a 1,000-watt hair dryer, it's the same, a watt balance. So know those standards. Know your trig. I think you're probably good on that. If I give you a triangle, which I will give you a triangle, and I'll ask you a side or an angle. If you know vectors, you should be good on that. Make sure with your unit conversions that you are doing the proper unit conversion, squaring the appropriate factors as you convert it. You'll have one of those. Okay? What else, folks? That's a lot. I think that's all the major topics. But I have more time. If you want to go over particular topics, I can spend more time on them. What? Oh, projectile motion? A little bit. Like, not projectile motion. Oh, no. I mean, that's why that lab was so hard. I felt bad for you guys because, you know, we haven't done any projectile motion. And I know you weren't the only one. That was probably one of the hardest labs. You guys that are doing it next week, you'll be at a bit of an advantage because on Monday we're going to jump right into projectile motion. So I'm sorry. I understand. Not on this exam. It's on exam 2. Exam 2 is going to be a whole other beast, and we'll slay that beast when we get to it. Exam 2 is the hardest exam of the semester. This isn't the easiest exam of the semester, but it's an easier. Probably the last exam is the easiest, or maybe the third exam. All right, so it sort of goes up, and then everybody yells like at the top of a roller coaster, and then it goes down. We have like a nice gentle thing, and then we like go through one of those big water things, and everybody gets all wet, and then we go home for Christmas. Okay. Other questions? Sure. Okay, well, I'm going to stop the recording, and then I'll tell you all the answers that are going to be on the exam.